Hi guys, welcome back to my channel. Please subscribe and like. Today we are going to today we're gonna do a book video and then reading a book about space. So let's continue on to chapter 2. Wait, hold on a second. Let me go back again. Wait, yeah. Yeah. Now we're gonna go to the solar system. It is on page 17 in the book almost fell grow. Anyways, I discovered it with my right hand. And I don't know why I just did that. Ha! There we go. Wait, we said the solar system is on page. Yeah, pretend that never happened. Pretend that never happened. He. 2 thumbs. Also, by the way, I'm using a holder for my phone and I keep moving the holder around because that's how you read a book. Anyway, this needs to be more like this. The solar system is a collection of 8 planets, more than 180 and millions of smaller objects all orbiting a star called the Sun. Staggering, the Sun contains more than 99% of all the mass in the solar system. 99.8% of all the mass in the solar system. And its enormous size means it has a very powerful gravitational force. This exerts a pull on the planets around it, just like Earth gravity. Earth pulls you to the ground and makes things fall. However, the planets will never fall into the Sun because the sideways movement of their orbits balances the sun's gravitational pull, like balls swing on a piece of string around a central point. Anyway, Alec. What it means is like the planet isn't going too fast to run away from to get separated from the Sun, or too slowly to crash into the Sun. It's just at the right one. It basically means in this way the Sun gravity holds the solar system together, keeping everything from the biggest planets to the smallest rocks in flat ordered orbits. The largest objects in the solar system out to the Sun are the planets. The innermost 4, Mercury, Venus, Earth, Mars, are the terrestrial/rocky planets with solid rocky surface. Beyond Mars, across a belt of millions of asteroids, lie the 4 gas planets: Jupiter, Saturn, Uranus, Neptune. They are gigantic in masses from 15 to 300 times that of Earth mass, and have no solid surface, as they are surrounded by layer after layer of clouds. The solar system started to form around 4.6, somewhere between 4.6 and 4.8 billion years ago, forged out of a cloud of gas and dust which collapsed under its own gravity. Over hundreds of millions of years, the cloud collapsed, speed up the rotation of the gas and dust, spread it into a flat disk in the same way a baker dough in the air to make a flat pizza. Slowly, a huge amount of compressed matter gathered in the center of the disk and made the Sun. The rest of the material clumped together to form the planets and their moons. From our earliest days, humans have been fascinated by the solar system. Spacecraft have documented every planet in its boundaries and borne witness to amazing sights from ice volcanoes on the dwarf planet Pluto to diamond hailstones on Neptune. But despite that, all that we learned, we still have many more discoveries to make. To make about the incredible system we call home. Next page. Actually, how many pages? Oh yeah, this is Mars. Actually, let's just read all of these. Mercury. Mercury is a hot rocky planet, just a third of the size of Earth. It is the smallest and fastest planet in the solar system, zooming through space at 170,500 kilometers per hour, and is also the closest planet to the sun. If you could start the Mercury surface, the nearby sun would appear 3 times larger than it looks to us on Earth. This proximity to the sun means Mercury is very difficult to see from Earth, except at twilight. However, about 13 times a century, observers can see Mercury past the face of the sun as a small dark dot. Like Earth, Mercury is a terrestrial planet. Is a terrestrial rocky planet with a solid iron nickel core and a surface surprisingly similar to our moon. Its smooth plains are thought to have been made by ancient lava flows, while its numerous craters was most likely carved out by meteor and comet impacts. Now, that's it. Just kidding. Above its surface, it has a very thin temporary atmosphere. This is continually created. The solar wind, a stream of charged gas released by the sun. The stream passes past the planet, leaves behind traces of hydrogen and helium gas, also knocking atoms off the planet's surface. The fine layer of gas, this helium gas, but also knocking atoms off the planet's surface. The fine layer of gas this makes rises and escapes. The fine layer of gas rises and escapes to space almost as soon as it was made, without a substantial atmosphere to trap the heat. Without a substantial atmosphere to trap the planet's heat, and with the sun's searing surface so near, Mercury experiences extreme heat and cold as the planet rotates. Yet its temperature soar to 340 degrees in the day, and then plummet to an air freezing -180 degrees at night. This is the most extreme range of temperature experienced anywhere in the solar system. The Messenger probe, operational 2011, discovered that despite these fierce daytime temperatures, there are pockets of water ice at Mercury's North Pole, where the planet has deep craters permanently sealed by the sun heat. Scientists believe that this water is most likely delivered to Mercury by icy comets Saturn into the planet in the early histories of the solar system. This is probably gonna take an hour. This is Venus. Venus and Earth are often referred to as sister planets due to their similar size, density, and internal structures. But this is where the similarities end. Unlike Earth, Venus is a hostile cloud-covered world with no atmosphere, with an atmosphere so thick and that its pressure surface is 90 times that on Earth. Not only this pressure cross anyone who stood in it on the planet's surface, but its carbon dioxide atmosphere would be poisonous to breathe, and the intense heat would boil them. Venus is the hottest planet in the solar system. From Earth, Venus appears the second brightest body in the sky at night, after our moon. But looking at it through a telescope, we can see nothing of a planet's surface beneath the thick atmosphere. Unbroken cloud cover, the rows reveal the distant atmosphere is almost 80 kilometers thick. 97% of it consists of poisonous carbon dioxide. The thick blanket of gas acts like a greenhouse, trapping heat from the sun so that it builds up, creating temperatures of up to 462 degrees, hot enough to melt tin and lead. The toxic atmosphere is also the site of vast, dramatic thunderstorms, which rain down sulfuric acid and can make around 20 lightning flashes a second. In order to get a global view of the surface of Venus, astronomers rely on space probes. The Magellan and Venus Express craft have both been sent to orbit the planet. They bounce radio off the planet to build three-dimensional maps and images of its terrain. The data collected to date has revealed a spectacular range of surface features, including dormant volcanoes and dunes, ancient lava plains, and rough highland regions. The absence of ancient craters also suggests that lava from extensive volcanic activity completely reshaped the planet when it was between 300 and 500 million years ago. Now it's our home planet, Earth. Our home planet, Earth, is the only body in the solar system known to support life. Since its formation 4.6 billion years ago, it has transformed into a violent molten rock into a world of deep ocean, losses in forests and sandy deserts, supporting incredible ranges of life form. It is a unique planet in the solar system for the vast volumes of liquid water which cover 2/3 of the surface and for its thin oxygen-rich atmosphere. Earth's atmosphere not only contains oxygen we breathe, but it also acts as a shield, protecting us from the sun radiation and burning up space debris such as meteors. They approach from the ground above the atmosphere and has 5 main layers. The troposphere, where water vapor is found, where all weather takes place. The stratosphere contains the ozone, the mesosphere, where meteors burn up. The thermosphere, where the International Space Station orbits, and the exosphere, which is very thin and merges into outer space. Beneath the Earth's surface, its interior is split into distinct layers. We can detect by studying waves after earthquakes. At its center is the core, a dense solid ball of nickel iron as hot as the surface of the sun. Above this is the outer core, where the whirlpools of molten iron generate Earth's magnetic field, and the mantle formed of solid rock so that it starts to flow like liquid. And the last of all is the hard crust, a fine outer layer surrounding the planet. This is so thin compared to the other layers that it is postage stamp on the outside of a beach ball. The crust and part of the mantle be together form huge slabs called tectonic plates. These shift over the molten part of mantle, moving a few centimeters a year. About the same rate that fingernails grow. Most geologic activity, including volcanoes, eruptions, violent earthquakes, and mountain formation, occurs as a result of plates slowly shifting. Alright, next planet. Never mind, we're going to the moon. Never mind, it's the moon. Anyway, the moon formed at the same time as Earth, a little bit after the Earth, when a body of rock about the size of Mars crashed into the planet. The planet name was Theia. The debris that was flung out from the impact slowly collected under gravity form a moon, kept in orbit around Earth by our planet's stronger gravitational force. As a result of this, Earth and Moon share stronger gravitational force. Many of the same materials. In fact, they are unique pairing in the solar system. No other satellite is so close in composition or size to its parent planet. To understand their relative sizes, imagine Earth as a basketball and Moon as a tennis ball 7.4 kilometers away. Using this comparison, the Sun would be of a large house 3 kilometers away. The Moon takes the same time to spin on its axis as it takes to complete a single orbit of Earth, around 27 days, which means you always see the same side of the Moon. This is known as synchronized rotation. When the Moon appears to shine the same sign, it's in fact reflecting the sunlight. Viewed from Earth, different amounts of its surface are lit up, creating the phases of the Moon. The distant surface of the Moon is covered by cloudy oil craters and dead volcanoes and wide lava-covered plains. The lunar plains are known as Maria, which is Latin word for sea. For Earth, they appear as shadowy areas, with the mountainous highlands appear much brighter. Since the Moon has no significant atmosphere to block the sun's rays to trap heat, temperature varies greatly between day and night, with an average temperature of minus 183 degrees at night and 106 degrees during the day. The Moon is the only body in space other than Earth where humans have set foot. Only 6 manned moon landings have taken place, starting with Neil Armstrong and Buzz Aldrin in July 1969, and the ending of Eugene Cernan and Harrison segment in December 1972. The rest of us can only image the incredible experience of standing on its dusty terrain, looking at an inky sky and glimpsing whole continents of Earth rotating into view. Now, this is the other side of the Moon, and these are the Moon phases. Yeah. Mars. This is gonna take forever and bye bye. I mean, literally, the last of the 4 terrestrial planets in our solar system, Mars, is known as the red planet for its distinctive rustic color, which can be seen with the naked eye. This bloody thing led the ancient Greeks to name the planet Ares after their thing, and today we know it as Mars after the Roman instead of the Greeks. Actually, hypothetical planets are named after Greeks, and in planets we know exist Romans or the Roman ones. Ancient Chinese astronomers also we know it as Mars after the this. And I'm gonna leave you to read it. I'm gonna leave him in hide. I'm very naughty. I'm done. I read a lot quicker in my head. Now do this. Done. Okay, I'm just reading it now. Okay, I'll stop doing it now. I'm gonna read it now. Now I'm gonna read. And I'm zooming in. And I'm literally zooming into now. No, let's do Jupiter. Jupiter is the largest planet in our solar system, so big that Earth could fit inside it to 1,200 times. Owing to its size and composition, is known as a gas giant. A planet, with a dense surrounding atmosphere, but with any solid surface you could not stand on it. At its inaccessible center is a solid core of ice, rock, and metal surrounded by liquid hydrogen. But moving further from the core, the planet's temperature and pressure decreases, and its elements start to act more like gases, giving way to a thick atmosphere of hydrogen and helium. In Jupiter's outermost layers, ammonia and sulfur create a swinging tapestry of red, yellow, white. Its colors is created by variations in temperature and composition. The gases are then pushed into bands of dark belts and bright zones by the planet fast rotating on its axis every 10 hours. Within the atmosphere, we can also see oval-shaped storms like hurricanes, largest of which is called the Great Red Spot. This has been raging continuously for more than 200 years, and is circling around Jupiter, and is 1.3 times larger than Earth. Well, it used to be 3, but now it's not. Circling Jupiter is at least somewhere between 90 and 100 moons, varying in shapes and sizes. The 4 largest are Ganymede, Callisto, Io, Europa, known as the Galilean satellites. After they discovered Galileo Galilei in 1610, each moon is an incredible world itself. Ganymede is the largest moon in the solar system. Callisto is the most created object known to us. Io is covered in active volcanoes, and Europa ice could be hiding an ocean twice as large as all of Earth's oceans combined. To date, 9 different spacecraft have collected images and data of Jupiter. They have discovered that Jupiter's magnetic field is almost 20,000 times as powerful as Earth, and have also beamed back including images of a faint set of rings around the planet. They are completely invisible to telescopes on Earth, though. Yeah, that's true. And dun. We know who it is. Speaking of things, it's Saturn. Okay, bro, I've been recording for almost 25 minutes at this point. Saturn is one of the 5 planets we can see in the night sky with just our eyes, and is the most distant planet to have been discovered by ancient civilization. It is a huge gas giant surrounded by bright, spectacular rings, for which is known as the ringed planet. Ring. I'm gonna let you read it. Surrounded by bright, spectacular rings. Okay, just kidding. Like Jupiter and Saturn is a gas giant made mostly of hydrogen, helium, some of the lightest elements in the universe. However, Saturn has just 30% of Jupiter's mass and the lowest density of any planet in the system. In fact, it will float in water. If you could find a bathtub big enough to hold it, unlike other planets, Saturn radiates almost twice as much heat into space as it receives from the sun. Astronomers think this is generated by droplets of helium falling towards the planet, converting from motion into heat energy. The heat powers storms and winds in Saturn's upper atmosphere with top wind speed of around 1800 kilometers per hour. Near the equator, faster than even Jupiter wind. About every 30 years, large storms also break out in this region, seen from above as the great white spot of ammonia crystals. Encircling Saturn is a complex system of rings made of billions of ice gas particles along fine dust and house-sized boulders. Scientists think the rings form when a medium-sized moon drift. Well, maybe it's 2 moons drifted very close to Saturn and was broken by the immense force of the planet's gravity. The rings are about 280,000 kilometers across, but only 1 kilometer thick if you build a model of a ring using a meter-wide plate. But the plate thickness would have to be 10,000 times thinner than a razor blade to represent the rings. Saturn has 62 known moons, mostly a mix of rock and water ice. Its moon, Titan, is the second largest in the solar system, with a dense atmosphere of nitrogen. The cold surface of Titan, he holds remarkable lakes of liquid methane. This moon is of great interest to scientists searching for extraterrestrial life, as it closely resembles the appearance of Earth at the time when life first evolved on our planet. Except for it's like very, 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 very cold. How many pages are there left? There better not be a lot. There's a lot. Then I never said that. Anyway, the Aquarius blue planet in the outer reaches of the solar system. Well, it's like more like bluish white color as a real color. Well, Cyanus, I think, was once considered to be a gas giant like Jupiter and Saturn. However, as astronomers have learned more about its composition and freezing temperatures, they have reclassified it as an ice giant. Uranus generates very little heat compared to the other planets, so even though it is not the distant from it is not as distant from the sun warmth as its neighbor Neptune. It is still the coldest planet in the solar system. Temperatures within its methane ice clouds can double to an incredible minus 220 degrees. Coincidentally, Uranus is unlike the gas giant as it has much more methane mixed with hydrogen and helium in its atmosphere. Then is found on Jupiter and Saturn. Then methane absorbs red light, resulting in the planet blue-green appearance, actually white. scattered across the seemingly smooth surface. You can sometimes glimpse storm in the upper atmosphere. This tracks up methane ice from the planet's lower layers and can appear as very bright spots when viewed with infrared telescopes. As it orbits the sun, it adopts an unusual position completely on its side, which is flipped over by 90 degrees. So its north pole points at the sun for half a year, and the south pole points at the sun for the remainder of the year. If it were possible for you to stand on the North Pole, you'd see the sun stay in the sky for 42 Earth without ever setting. After this incredibly long summer, at the sun would finally drop below the horizon, and you'd enter 42 Earth of winter darkness. Sun indicates the planet's surprising rotation axis may have resulted from a collision with a large object which tipped the planet onto its side. This force of this impact could have created Uranus things well in the past would be a lot bigger. These could have formed a broken piece of moon crashing into each other. Or it just ripped another moon apart. Or maybe the one moon used to be bigger, Miranda, they got sucked in and it became smaller. Uranus got it. Anyway, last planet, but not the last one. Neptune, the outermost planet in the solar system, gets its beautiful blue color from the methane in its atmosphere. This deep blue atmosphere is the location of the fastest storms in the solar system. Destructive forces of a Category 5 hurricanes on Earth. Bro, I've been reading for more than 30 minutes. The most intense wind known as on our planet. Neptune also experienced smaller storms which appear as dark spots on its surface, similar to Jupiter's Great Reds, but these dark spots are shorter lived than those on Neptune. Neighboring planets, rather than raging for centuries, they can disappear within the space of just a few years. They are often accompanied by clouds of ammonia and water ice, which can be seen as bright white spots in the planet's upper atmosphere. Although, by the way, Neptune is not dark blue; it's actually light blue, or not as light as Uranus, but still. Amazingly, scientists think Neptune lower atmosphere may also experience diamond rain, where rising temperature and pressure cause methane to form a solid diamond which drop down to the planet's center, cause methane to form solid diamonds which drop down to the planet's center. Surrounding Neptune are 5 faint rings made of tiny particles which may have been ejected from orbits tracking the planet's moon. Out of 14 known moons, the most prominent and largest is Triton, which was discovered in October 1846, just 17 days after Neptune itself was officially recorded. Triton itself is mostly made of rock and ice, with a terrain that mixes craters and smooth plains. Plumes of dust and nitrogen erupt from its surface, from its cryovolcanoes, they call, to give it a very thin atmosphere, and with an average temperature of actually 2,235 degrees. That is the coldest known object in the solar system. Imagine being 272 degrees. Anyway, let's talk about the dwarf planets now. Around and beyond the orbits of the 8 planets, the solar system is crowded with other objects of ice and rock, no larger than a fist, to objects as big as the planets themselves. So what makes a planet a planet? In 2006, astronomers answered this question and set out three criteria is that all planets must meet. Firstly, a planet must be in orbit of the sun, otherwise it's some rogue object. Secondly, it should have enough mass and gravity to pull itself into a spherical shape, otherwise it's asteroid, meteorite, comet. Thirdly, its path around the sun must be clear of other objects for many years. For many years, astronomers classified Pluto as a planet. While it meets the first two criteria, it fails on the third count because it shares its neighborhood with other icy objects. So in 2006, its 76th stint as the smallest planet in the solar system came to an end, and Pluto was given a new label of the dwarf planet. Astronomers think there could be dozens of dwarf planets beyond distant orbits so far. But so far we have identified five dwarf planets. Well, the other dwarf planets, what they call dwarf planet candidates or whatever, as well as Pluto. We know of Sirius, which is between Mars and Jupiter, not in the Kuiper Belt. Eris, Makemake, and Haumea. Most of these are located in the Kuiper Belt, stretching from Neptune orbit to around 15 billion kilometers around the sun. But much closer to us is Sirius, the largest object in the asteroid belt between Mars and Jupiter. It was long considered to be an asteroid, and was in fact the first asteroid ever discovered. However, it reclassified as a dwarf planet in March 2006 and was the first dwarf planet to be visited by a spacecraft. When NASA Dawn mission entered the first dwarf planet to be visited by a spacecraft. When NASA Dawn mission entered the first dwarf planet to be visited by a spacecraft, when NASA Dawn mission entered into orbit around Sirius in 2015. In July 2015, New Horizons spacecraft then made the first flyby of Pluto, some 9 years and 4.8 billion kilometers after the probe was launched in 2006, swooping just 2,500 kilometers above Pluto's surface. The images it sent back showed the amazing varieties of surface features such as craters, cliffs, and layers of nitrogen ice. Anyway, here are the dwarf planets. Also, by the way, this one is Pluto, and the red one is Pluto, and the gray one is Charon. Pluto's moon. You can call it another dwarf planet since it's like orbit because Charon is so heavy that it pulls Pluto a little bit. But they also orbit around the sun at the same time. Also, this happens with Earth too, but the moon is much less massive than the Earth instead of Charon. And Charon is very, 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 spherical. Okay, now let me do this. Comets and asteroids can be thought of the solar system leftovers, the material that remained after the sun and the planets and the moons all formed around 4.6 billion years ago. These objects orbit the sun on an oval path, sometimes staying persistently close to the planets or even crashing into them. But apart from these comets and asteroids are very different from each other in composition and behavior. Comets are compact balls. Very different. Comets are compact balls of ice and dust, like huge dirty snowballs barreling through space. They began their journey in the farthest reaches of the solar system, originating in the Kuiper Belt, some 4.5 to 15 billion kilometers from the sun, or the Oort cloud, a 7,500 billion kilometers away from the sun, which is like 4,000 AU at its closest. Excuse me, why do I burp so much? As the coast brings them closer to the sun, they begin to warm up, and some of the ice turns into vapor. This forms a thick cloud of coma of gas and ice around the comet's core. The solar wind page 20 blows some of this back and results in a brilliant tail tails streaming behind the comet. The largest comets have trails of millions of kilometers long and bright enough to be seen from Earth. In contrast, asteroids are made of metal and rocky material which have a regular shape, often resembling potatoes. And this is a result of collisions with other space objects after which the gravity is not strong enough to pull them into a spherical space. The largest asteroid orbit the Sun in a region between Mars and Jupiter called the asteroid. Where collision can knock an asteroid off its place and send it hurtling into the wider solar system. Many pieces of debris and thus also drift to the solar system. Sometimes pea-sized pieces of the interplanetary material enter Earth's atmosphere and burn up. We see these meteorites or shooting stars. Beautiful bright trails streaking across the sky. Any debris that enters our atmosphere is known as a meteoroid. But if it survives, falls to the atmosphere, it's known as a meteoroid. These range in size to pebble-sized lumps to boulders weighing more than 20 tons. Thank you for watching this video. Please subscribe and like. It took me like forever to make this video. It was so long, and they better not be uploading issue. Bye.